Jupiter, the fifth planet, the first gas giant, the largest planet, the red dot planet. Jupiter is all of these things and more. It takes 4,333 Earthen days to circle the sun. This, the size of a basketball compared to Earth's small grape. A 10-hour day, but a 12 Earthen year. Composed of mainly hydrogen and helium, encircled by 75 moons, a red storm, 2 Earth's big spits and burns on its surface. This is where the newest technological wonder will go next. Falling into orbit soon will be Project Zeus.
Project Zeus's base is an elliptical orbit on Jupiter. It is a giant space station with housing, workout rooms, gardens, a chicken farm, schools, and medical rooms. And because of the elliptical orbit, when the base gets the closest to Jupiter, it'll speed up because of mass and weight. When it does, we'll be able to slingshot a small spacecraft, our mining probe carrier, off to Europa or Titan to collect resources including phosphorus, hydrogen, nitrogen, rare earth metals, and more. Keeping our base energized is a key component to sustaining a stable life in our base. It is how we'll be able to keep our base up and running. We'll be using RTG, which is radiostopic thermal generators to handle large, long-term energy and heat from the use of radioactive metals. We can use the thermal energy to heat the space station and the energy output for electronics. For a smaller scale, we can use hydrogen fuel cells, or for short, HFC, which will be used to produce energy, but is also important because as a waste product it produces water. The hydrogen fuel cells work as you put in hydrogen and oxygen, it takes away the electrons from the hydrogen, creating an electrical current, leaving the hydrogen protons and neutrons with the oxygen, which will eventually create water as a byproduct. The RTGs for our large long-term energy will be used by having a radioactive mineral or metal within the coupler that will generate heat, which will then be used to generate electricity. The normal downside with both of these is the exposure to humans and long-term effects, but luckily in the vacuum of space, hydrogen has a harder time combusting, and because we're already well insulated from radiation, having the RTGs inside of an insulated cover plus extra insulation on rooms will allow for long-term protection of our citizens.
Our mission isn't just to put people on a spacecraft and send them into space. It's to explore beyond Mars, to extend the reach of humanity further. As we go through the solar system, we grow and expand our knowledge of how it formed. Jupiter is a key planet, being the largest one out there. It is also a gas giant, meaning that it is primarily made up of gases. We hope to discover more about the composition of the moons of Jupiter as well. Our spacecraft will not be entirely self-sustaining. We will need minerals and resources that are available on the neighboring moons. We will be able to find them all on Europa, a moon of Jupiter that has been found to have water underneath its surface. There will be more on that later, though. As we orbit around Jupiter, our spacecraft will fling out pods that are designed to collect resources from the moons.
For transportation in and around the base, we will use RTGs to power mining probes and solar energy to power the rovers. Vehicles that are used solely for travel around the colony will be powered by the base's control center. Mining probes will land on the moons of Jupiter using retro rockets and will exit the moons using 4 thrusters equipped around the pod, allowing them to escape the orbits. They will land on the space station using retro rockets and then will transport material to the station's material storage. The base will need people to be working to keep everything in the colony functioning. To help this, the people of the colony will take up occupations such as farmers, doctors, mechanical engineers, teachers, scientists, and members of the government. The citizens will be paid using the same format as USD, but electronically. It will function by the use of a satellite attached to the base. Workers will be hired based on former occupations and by experience. With these jobs, the citizens will be able to afford luxury goods and services such as babysitting, house cleaning, etc. In order to keep our colony stable, we need some form of government. In our base, the colony will be a self-governed democracy. All decisions within the spacecraft will be voted for by the people. The colony has a code of law similar to that of the United States of America, and all government officials and law officials will both be voted upon by the citizens.
In our base, we will feed out the colony with freeze-dried foods, a garden, and chickens. The plants will grow in small greenhouse structures, each around the size of a queen-size bed. We can alter the growing conditions in each of the pods specific to the requirements of each plant. In the greenhouses, we will be growing an assortment of foods such as ginger, spinach, potatoes, tomatoes, winter squash, and broad beans. Ginger, spinach, broad beans, and winter squash will all be in the same planting pod because they require the same soil type and spacing. This pod will be kept at 70 degrees, which is suitable for all the plants growing in it. Tomatoes and potatoes will be planted in the same pod. This pod will also be kept at 70 degrees. Along with the garden, we will have a coop of chickens, enough to feed the colony. For food, the chickens will bring along a small supply of chicken feed, and we will transfer them over into a feeding on leftover scraps from the gardens. Their water will be connected to the watering system in place for the greenhouses. They will be very useful for their protein and their manure, which will be used for the fertilizer.
There are 6 major keys to supporting life on our base. These components include thermal insulation, water production, oxygen production, radiation protection, and carbon removal. We have found solutions for each of these needs. For producing water for the citizens in our colony, we will be using membrane distillation, which is the process of taking urine and turning it into water. To go into more detail, it is a procedure for splitting 2 aqueous solutions separated by the microporous hydrophobic membranes at various temperatures. For thermal insulation, we are using MLI. MLI is thermal insulation composed by multiple layers of thin sheets and is often used on spacecrafts and cryogenics. For oxygen production, we will be using the process of water electrolysis. This is a procedure that uses electricity to decompose H2O into oxygen. To protect ourselves from radiation, we will be using HDPE plastics, specifically Borotron HDO50. It is used to attenuate and absorb neutron radiation, and it is beneficial in many ways, such as being easy to handle and fabricate, and is also very durable in a wide range of temperatures. For our last component to support life on our base is carbon removal. We will be using water sorbents instead of zeolite because the pros of water sorbents far outweigh the pros of zeolite. The system's intended use is for ventilation applications and use of a direct air and liquid contactor. The contactor is made up of a divided manifold with 3D printed rigid barriers that contain capillary channels for the deployment of small films of liquid sorbent. Surface tension and capillary forces keep the liquid in position, and when exposed to air, the liquid absorbs carbon dioxide and humidity from the surrounding atmosphere and creates the process of liquid sorbent carbon dioxide removal. It detoxifies our air and allows us to breathe. Along with sending 1,000 people into space, we have to make sure that they continue to stay a relatively level population. Our plan is to have each couple only be allowed to conceive 2 children. If we allow more than 2, we would quickly become overpopulated. But if we only allow 1 child, we would eventually all die off and no one would be left to run the spaceship. Along with this, anyone who is found to have more than 2 children will be given a set amount of time in solitary confinement, set apart from other humans. We are planning on being a very strict society about the 2 children rule, as the balance of around 1,000 people could be easily offset. Social isolation is going to be a very common punishment, along with strict, grueling community work, and even possible death for reprimandment. We hope to have this world be a more peaceful version of Earth, but should the need come, we will implement punishments. Keeping our citizens happy and healthy is extremely important for the project to thrive. We will keep 1,000 people happy and healthy by feeding them plenty of vitamins, calories, proteins, and grains. Project Zeus will have an exercise room with machines that will have a powerful elastic strap pulling them down to stimulate a gravitational pull. We will offer snacks like granola, nuts, and freeze-dried ice cream sandwiches for people to occasionally eat. We will have scheduled class times from 9 a.m. to 4 p.m. for children and young adults, like a normal school system in America. An occasional reward such as ice cream, food, and free time to relieve their mental health. Counselors will be offered as well to make sure our citizens remain happy. Although this project is merely an idea in the making, we believe that Project Zeus could be the next small step for man and large step for mankind.